In this video, we are going to subnet a Class C network address, but instead of being given the number of subnets to create, we will be given the number of hosts each subnet should have. So let's get started. We are going to subnet the classful network address of 192.168.0.0/24 so that each subnet has at least 60 hosts. The first question we need to ask ourselves is, how many host bits do we need so each subnet can accommodate 60 hosts? If we have 5 host bits, each subnet would have 30 hosts. If we have 6 host bits, each subnet would have 62 hosts. To satisfy this, we need to have 6 host bits for each subnet. Each address has 32 total bits. If we subtract the 6 host bits, we'll be left with 26 total network bits. That's enough information for us to complete this exercise, but just to be more complete, let's find out how many bits we're actually going to borrow. We have 26 total network bits minus the 24 original network bits. That will leave us with 2 borrowed network bits. The next question we need to ask ourselves, what is our new subnet mask? Well, we already determined that we have 26 total network bits, so we could just put that in CIDR format and say /26. If we wanted to put it in binary, all we need to do is turn on the first 26 bits of our subnet mask. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. These are our 6 host bits. If we wanted to put it in decimal, 255.255.255.192. This is 255.255.255.192. So this is our subnet mask in CIDR format. This is our subnet mask in binary format. And this is our subnet mask in decimal format. So the next question we need to ask ourselves is, what is the value of the last network bit? This is a value of 128. This is a value of 64. So our answer is 64. The last question we need to ask ourselves is, what octet is the last network bit in? Here's the last network bit. It's in the 1, 2, 3, 4th octet. So now we can start subnetting. Just like the other video, we always start with subnet number 0, and it always matches the classful network address, 192.168.0.0. The next subnet, we're going to increment by 64s in the 4th octet. So it will be 192.168.0.64. The next subnet is 192.168.0.128, 64 plus 64. The last subnet is 192.168.0.192. We borrowed 2 network bits, so 2 to the 2 equals 4. That's the number of subnets we've actually created. We really didn't need this information But just to be more complete, I showed you how many borrowed bits we ended up with. What we were really concerned with is how many host bits did we need. Once we have that information, that's enough to get our new subnet mask. We know we needed 6 host bits, so that's going to leave us with 26 total network bits. So the next step is putting it in binary so we can find our broadcast address. So I'm going to copy everything down. Last time I converted this whole entire address into binary. This time I'm not going to do that. I'm only going to convert our original host bits. We originally had 8 host bits. We have 32 total bits minus the 24 original network bits. That leaves us 8 host bits. So I'm only going to convert what were originally host bits into binary. These first 24 bits, they were part of the original classful address and they won't change. So there's no reason to convert them. So I'm going to convert 0 into binary. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to convert 64 into binary. Now I'm going to convert 128 into binary. Now I'm going to convert 192 into binary. If you notice, these are our 2 network bits. It started off that both of the borrowed network bits were turned off, and by the time we get to the last subnet, both borrowed network bits will be turned on. So this is our subnet address. Now I'm going to find our broadcast address. I'm going to copy this over. I'm going to turn on the last 6 bits, which are host bits. In decimal, this will be 63. So I'm going to do it for the next subnet address. So again, I'm going to turn on the last 6 bits. Then I'm going to convert this number back to decimal, which is 127. Let's go to the next subnet address. So again, I'm going to turn on the last 6 bits, then convert to decimal. This number in decimal is 191. So we're on our last subnet. Again, I'm going to turn on our last 6 bits and convert it to decimal. So that's our broadcast address for each of the subnets. So our last step is find the range of usable hosts. So I'm going to copy this down, and we're going to find our range. I'm going to put it on a new row. To find our first in the range, I'm going to increment this by 1. To find the last in the range, I'm going to decrement this by 1. And again, I'm going to remind you that you're always going to increment in the last octet and decrement in the last octet, because that's where our last host bit is. This is essentially being turned on or off. So 192.168.0.1 to 192.168.0.62. This is the first in the range, and this is the last in the range. From here to here, those are IPs I can actually assign to a device. I cannot assign the subnet address or the broadcast address to a device. That's why we have this -2. That's for the subnet address and that's for the broadcast address. If I looked at this in binary, the only difference between this and this in binary is the last bit will be turned on. The only difference between this and this in binary is the last bit will be turned off. So let's find the range for the next subnet. 192.168.0.65. One more than this. To 192.168.0.126. One less than this. Let's look at the next subnet address. 192.168.0.129 to 192.168.0.191. and our last subnet. 192.168.0.193.2.192.168.0.254. One more than this for the first in the range, one less than this for the last in the range. So the only thing different between this and what we did in the previous video was how we determined our subnet mask. And that's all the statement is doing, is telling us our new subnet mask. So instead of trying to determine our subnet mask based on the number of subnets we need, we created our subnet mask based on the number of hosts each subnet needs. So that's really the major difference between this video and the last video. Other than that, all of this down here is the same. Okay, that's it for this video. Thank you.